When you look up at the night sky, the moon is always there. We tend to take it for granted. But to scientists, the moon is still a world full of mysteries. How was it born? Why does it always show us the very same face? And what would have become of the Earth if the moon had never existed? Today, we'll explore the many mysteries of the moon and the deep, unbreakable bond between the moon and the Earth. By the end of this video, the moon in your night sky will look completely different. So sit back and enjoy the journey. First, the basics. The moon sits about 384,000 kilometers from Earth. Even on a bullet train at 300 kilometers an hour, the trip would take 53 days. Light, though, makes it in just 1.3 seconds. So the moonlight you see is actually 1.3 seconds old. By the way, 53 days on a train. Even in first class, your back would give out long before you arrived. The moon is about 3,474 kilometers across, roughly a quarter the size of Earth. And that's surprisingly huge for a moon. Across the solar system, moons are usually tiny compared to their planets. No other planet has a moon this large relative to itself. Our moon is truly special. Here's a strange coincidence. In our sky, the sun and the moon look almost exactly the same size. The sun is about 400 times wider than the moon, but it also sits about 400 times farther away. Thanks to this miracle of numbers, the moon can perfectly cover the sun, giving us a total solar eclipse. Coincidences like this are vanishingly rare in the universe. The moon is famous for its phases: new moon, crescent, half, then full. The phases happen because we see the sunlit side of the moon from changing angles. From one new moon to the next takes about 29.5 days. Ancient people built their calendars on this rhythm. In fact, the word month comes straight from the moon. You've probably heard the word supermoon. It happens because the moon's orbit isn't a perfect circle, but an ellipse. When the moon's closest approach lines up with a full moon, we get an unusually large, bright supermoon. And that giant moon you sometimes see near the horizon? It isn't actually bigger. That's an illusion created by your own brain. The moon's environment is brutal beyond imagination. With almost no atmosphere, the surface hits about 110 degrees Celsius by day and plunges to minus 170 at night. And a single lunar day lasts about a month, so 2 weeks of blazing heat are followed by 2 weeks of freezing dark. With no air, even the daytime sky is pitch black and utterly silent.
Quiz time. About what fraction of Earth's diameter is the moon? 1, 1/2. 2, 1/4. 3, 1/10. The answer is 2, about 1/4. That's surprisingly large for a moon.
So how was the moon actually born? This was a puzzle that troubled scientists for generations. There were once 3 ideas. The sister theory, born alongside Earth. The daughter theory, split off from Earth. And the capture theory, a wanderer caught by Earth's gravity. But each had a fatal flaw, and the debate dragged on for decades. Today, the leading explanation is the giant impact theory. About 4.5 billion years ago, a body the size of Mars, named Theia, struck the newborn Earth at an angle. The colossal debris thrown out by that collision circled the Earth, clumped together, and became the moon. Some simulations suggest the moon took shape in as little as a month to a century. But even this theory leaves a mystery. When we study the moon rocks Apollo brought home, the oxygen isotope ratio, a kind of chemical fingerprint, is almost identical to Earth's rock. If a lot of Theia were mixed in, they should differ more. Why are they so alike? The moon's origin is still not fully solved. You've surely heard that you can see a rabbit on the moon, and that rabbit is always in the exact same spot. That's because the moon always shows us the same face. From the surface of the Earth, we can never directly see the far side of the moon. Ever. Why does this happen? Because the moon's spin and its orbit take exactly the same time. The moon circles Earth in about 27 days, and it also turns once on its axis in about 27 days. This is no accident. Over vast ages, Earth's gravity slowly braked the moon's spin until it locked in place. We call this tidal locking. The rabbit's pattern is actually terrain called the seas. There's no water, though. They're plains of dark basalt, ancient lava that once flowed and hardened. The dark areas are the seas, and the bright areas are the highlands, scarred with countless craters. Interestingly, people see different things in those patterns. In Japan, a rabbit pounding rice. In southern Europe, a giant crab. In northern Europe, an old woman reading a book. In Arabia, a roaring lion. Looking up at the very same moon, cultures everywhere wove their own stories. So what does the never-seen far side of the moon look like? Humanity first laid eyes on it in 1959 when the Soviet probe Luna 3 captured it on camera. And when the images came back, scientists were stunned. The far side had almost none of the dark seas that cover the near side. The near side and far side look like two completely different worlds. The far side has a much thicker crust and is riddled with craters. Why such an extreme difference? We still don't really know. One bold idea even suggests Earth once had two moons, and the smaller one slowly collided and plastered itself onto the far side. So familiar, yet so mysterious. From here, let's turn to the bond between the moon and the Earth. The most familiar effect the moon has on us is the rise and fall of the tides. Sea levels slowly rise and fall about twice a day. And the culprit behind it all is the moon, 384,000 kilometers away. The moon's gravity pulls the Earth's oceans toward it. The water on the side facing the moon bulges up into high tide. Strangely, the water on the opposite side bulges too, because the Earth itself is pulled toward the moon, leaving that water behind. As the Earth spins beneath these bulges, we get 2 high tides a day. The tides are woven deep into life on Earth. Mudflats exposed at low tide become cradles for countless creatures. Corals spawn all at once on the nights of the spring tides, and sea turtles ride the high spring waves onto the beach to lay their eggs. The moon's rhythm is the rhythm of life in the sea. And when the sun and moon align at new and full moon, we get the largest tides of all, the spring tides. Now, here's a shocking fact. Right now, this very moment, the moon is slowly drifting away from Earth. The speed? About 3.8 centimeters a year, roughly the rate your fingernails grow. How do we know? During Apollo, astronauts left mirrors on the moon's surface. By firing a laser and timing the reflection, we can measure the distance to the moon down to the centimeter. Why is it drifting away? It traces back to the tides. Friction between the oceans and the seafloor gently breaks Earth's spin, and that lost momentum is handed to the moon, nudging its orbit outward. In other words, Earth's day keeps getting longer. When the moon was newly born, a day on Earth was only about 5 hours long. The proof was hiding in a surprising place: coral fossils. Like tree rings, corals record daily growth bands. Studying coral from about 400 million years ago, we found a year held about 400 days. A day back then was about 22 hours. Earth's spin really was faster. And in the distant future, as the moon drifts farther still, total solar eclipses will vanish from our skies.
Next question. How far does the moon drift away from Earth each year? 1.38 centimeters. 2. 3.8 centimeters. 3. 38 centimeters. The answer is 2. 3.8 centimeters a year, about the rate your fingernails grow.
What if the moon had never existed? The truth is more terrifying than you'd think. Earth's axis is tilted at 23.4 degrees and stays remarkably stable over long stretches of time. That tilt gives us the seasons, and the hero keeping it steady is the moon's gravity. Mars, which has no large moon, is thought to have wobbled on its axis by more than 10 degrees over millions of years. If Earth's axis wobbled like that, we'd suffer catastrophic climate swings, equators freezing, poles scorching. Our stable seasons and gentle climate exist only because of the moon, a giant counterweight. The moon is the guardian of Earth's climate. What's more, without the moon, days would be far shorter and fierce winds might rage across the planet. Nights would stay pitch dark with no moonlight, and the tides would be barely a ripple. Life might have evolved down a completely different path. It's no exaggeration to say we are here today thanks to the moon.
Final question, and a tough one. If the moon suddenly vanished, what would be the most serious consequence for Earth? 1. Days become half as long. 2. The seasons go haywire and the climate turns violent. 3. All the oceans evaporate. The answer is 2. The seasons go haywire. The moon's gravity quietly steadies Earth's tilt, and without it, our planet would wobble.
Next, the mysteries hidden inside the moon. Apollo placed seismometers on the surface, and to everyone's surprise, the moon has quakes too. They're called moonquakes. There are deep moonquakes from below 800 kilometers, quakes from meteorite impacts, and more. And the moon shakes in a way utterly unlike Earth. Once the moon starts shaking, it rings like a bell, sometimes vibrating for nearly an hour. That's because the moon's interior is bone dry, with almost no water to absorb the shaking. The moon's gravity also has strange lumps, called mascons. In some places gravity is stronger, enough to disturb the orbits of spacecraft circling the moon. In 2017, data from Japan's lunar probe Kaguya revealed a giant cavern beneath the surface, some 50 kilometers long. It's thought to be a lava tube, the trace of ancient flowing lava. Inside, no meteorites and no harsh radiation can reach. As a site for a future lunar base, it's drawing attention from around the world. July 20th, 1969. Commander Neil Armstrong of Apollo 11 became the first human to set foot on the moon. That's one small step for man, one giant leap for mankind. With those famous words, humanity left its footprints on another world for the very first time. Across the Apollo program, 12 astronauts walked on the moon and brought home about 382 kilograms of moon rock. Analyzing it revealed the moon's age of about 4.5 billion years and gave clues to the giant impact theory. And the footprints left on the moon, with no wind and no rain, are said to remain for millions of years to come. One thing that tormented the Apollo astronauts was the lunar dust, called regolith. Shattered over eons by meteorite impacts, the dust is as fine and sharp as broken glass. It clung to spacesuits with static electricity and jammed into equipment, causing failures. The astronauts reported the moon dust smelled like gunpowder. Dealing with this nasty dust is still a major challenge today. Today, lunar exploration is entering a new era, sparked by the discovery of water. At the moon's south pole, there are crater floors where sunlight never reaches, called permanent shadows. Observations show water exists there as ice. Water means drinking water and split apart, even rocket fuel. The moon's south pole has become prime real estate for space development. Japan is in the game too. In January 2024, Japan's probe SLIM landed on the moon, making Japan the fifth nation to achieve a lunar landing. And it was a world first, a pinpoint landing, accurate to within mere tens of meters of the target. This technology will be essential to lunar exploration ahead. The International Artemis program, led by the United States, is also underway. It aims to return humans to the moon after half a century and build a lunar orbiting station called Gateway and a base on the surface. Japan is taking part too, and the day a Japanese astronaut stands on the moon may not be far off. The moon is becoming humanity's frontier once again. There's another reason the moon draws attention: resources. The lunar soil contains helium-3, a promising fuel candidate for next-generation fusion power. There's titanium, rare metals, and more, believed to lie buried on the moon. In the 21st century, the moon is at once a subject of science and a front line where nations compete to develop it. So how was it? The moon was born from a giant impact 4.5 billion years ago, nurtured ocean life through the tides, and has steadily steadied Earth's axis. And even now, drifting away 3.8 centimeters a year, it quietly watches over the Earth. The moon is a living witness to Earth's history and a benefactor to all life. Tonight, if the moon is out, stop for a moment and look up. What's up there isn't just a pale white disk. It's a partner the Earth cannot do without, holding 4.5 billion years of story. If you enjoyed this video, a like and a subscribe would mean a lot. Thank you so much for watching to the end.